Let's take a look at the tangent of theta function. Now, tangent is going to be a bit different than sine and cosine. And the reason that's the case is because it's a ratio of sine divided by cosine. So, let's first graph our tangent function. Y equal tangent of x. I'll clear the other ones. With tangent, because it's going to behave asymptotically at certain points, we're not going to have a maximum or a minimum on the graph. So for the window settings, the domain is going to remain the same, -6 to 12.5. That's basically -2 pi to 4 pi. And the y values can go from -2 to 2 or -4 to 4 or -6 to 6, whatever you want to choose. We'll leave it at -2 to 2 and see what happens. When I graph that, you'll get something like this. That's a lot of graphs on there. So what's happening is, the straight lines you see, those are the asymptotes. Okay, those straight lines, they are the asymptotes. The asymptotes are going to take place wherever the function is undefined. The function is going to be undefined wherever, because tan theta is sine theta over cos theta, it's going to be undefined wherever cosine is 0. The bottom part is 0. So if I take a look at the graph, 0, 2 pi, 4 pi, -2 pi. Actually, I'll change it up. This one, because I'm going to have too many graphs, I'll actually change the domain here. So I go from 0, I'll call this pi, and I'll call this 2 pi. I'll call this -pi. And you'll see in a moment why I'm changing that domain. 0, pi, 2 pi, -pi. Which means half of that's going to be pi over 2. This is going to be 3 pi over 2. And then each subdivision is pi over 4. So we're going to have our asymptotes wherever cosine of theta is 0. Cosine of theta is 0 at pi over 2 and 3 pi over 2. So at pi over 2, I'm going to have an asymptote. And at 3 pi over 2, I'm going to have an asymptote. Tangent is going to be 0 wherever the top part is 0 of that fraction, which means wherever sine is 0. Sine is 0 at 0, pi, and 2 pi. Similarly, at -pi, I'm going to have a 0, and at -pi over 2, I'm going to have an asymptote. Right, so the asymptotes and zeros can be decided just by looking at the ratio, sine over cosine. Now I need to fill in the gaps. You'll notice that if I go back to the sine and cosine functions, right, here's the sine function. Sine is getting divided by cosine. So between 0 and pi over 2, if you look at the domain between 0 and pi over 2, which is this area right here, right, sine function is increasing from 0 all the way to 1. The cosine function is decreasing from 1 all the way to 0. So what you're going to have is you're going to have a number that's increasing divided by a number that's decreasing as you go from 0 to pi over 2. A number getting bigger divided by a number getting smaller. What's going to be the end result? Number getting bigger divided by number getting smaller. Number getting bigger divided by number getting smaller. What are you going to end up with? Number getting bigger and bigger and bigger and bigger and bigger. So starting at 0, right, because sine divided by cosine, 0 divided by 1 is 0. As we move from 0 to 2 or pi over 2, 0 to pi over 2, the first rotation from 0 to pi over 2, you'll notice that our tan function is going to go from 0 to being undefined. And in fact, I'll be a little bit more specific. At pi over 4, which is in between pi over 2 and pi, at pi over 4, it's actually going to be 1. Because the sine and cosine are going to be the exact same value at pi over 4. It's actually going to be 1. It's going to look something like this. Again, I can use a unit circle if I want to. This is 0, this is pi over 2, this is pi, 3 pi over 2. As I go from 0 to pi, I go from 0 all the way to undefined. Right? The tangent goes from 0 to being undefined, right? Positive undefined. Similarly, as I go from pi over 2 to pi, you'll notice that it goes from undefined back to 0, which means it's going to go from either positive or negative undefined back to 0. But I need to check the sign. So what's going to happen is if I go back and take a look at my sine and cosine graph, as I go from pi over 2 to pi, which means I'm now looking at this region right here, pi over 2 to pi, you'll notice that the sine value is going from 1 all the way to 0, and the cosine value is going from 0 all the way to negative 1. One of those values is negative. So a positive number divided by a negative number is going to give you a negative number. It's going to be in the negative region. And you're going from values that are getting smaller, bigger to smaller, to values that are getting smaller to bigger negative number. And the end result is going to be values that are negative, negative really big, all the way up to 0. So it's going to look something like this. It's going to behave asymptotically. Similarly, as you move from pi to 3 pi over 2, you went from tan being 0 all the way to tan being undefined again. So tan is going to go being undefined again. It's periodic as well. Similarly, as you go from 3 pi over 2 to 2 pi, it's going to go from being undefined all the way to 0. It's going to go from being undefined all the way to 0. And undefined in the negative region. And I can extend this graph in the same way over to the left hand side. It's going to give you something that looks like this because it's periodic. So that's going to end up being your tangent of theta graph. The red graph is y equals tan theta. What do you notice different about the tangent of theta graph compared to the sine and cosine? First of all, you'll notice there's no amplitude, right? Because it's continuous, it keeps on going. There's no amplitude, it's not oscillating, it's not hills and valleys. It's asymptotic, so no hills and valleys, so it's not going to have an amplitude. What do you notice about the period of the tan graph? Is it still repeating every 2 pi units? 180, not over pi, 180 or pi units, right? Either one or the other, either 180 degrees or pi. So it's repeating every pi units. You'll notice the same point repeats itself every pi units. So when you look at the graph, from here to here, the period ends up being just pi units. And that's one of the properties of a tan function. It's actually going to repeat itself every pi units. Or if you look at the distance from here to here, it's pi units. Every pi units it's going to repeat itself at the same point. Now the next part's going to get a bit messy, so hopefully you're okay with that. Because we have a lot of asymptotes coming into play, when we do our horizontal expansion or compression, we're going to have a whole bunch of messy asymptotes showing up that are not quite there yet. So I'm just going to make a little bit of space here by erasing that. Okay, 2 theta means it's going to get compressed by a factor of 1/2, which means wherever your current asymptote is, so I'll change colors. Let's say we go green for this one. Wherever your current it's going to get cut by a half. So right now it's at pi over 2, it's going to end up at pi over 4. Different color. Let's go blue. The zeros were at pi, the zero is not going to happen at pi over 2. The next one was at 3 pi over 2, it's going to happen at 3 pi over 4. Right, then you're going to have another 0, and then another asymptote. And then another 0, and then another asymptote. And then another 0. Similarly, there was a 0 here, so another asymptote here. Another 0, another asymptote here. with a 0. Right, so your graph's going to get squished horizontally by a scale factor of 1/2, so it's going to give you something like this. Right, it got squished horizontally. Similarly, same thing here. Same thing here. Like I said, it's going to get a bit messy to draw this out all in the same graph. I'm going to try and do our best. Right, so the blue one is y equals tangent of 2 theta. Got compressed by 1/2. And then I'm not going to bother drawing tangent of 1/2 theta on the same graph because it's going to be super messy, but you get the idea. The tangent of 1/2 theta is just going to be the horizontal expansion of that. Right? If I draw the same thing on there, we won't be able to tell which graph is which. Right? So I'll leave that one for your imagination. Are we okay with the general properties so far of these graphs? Right? Sine and cosine are really similar. Tangent is a bit weird. It's kind of behaving in its own way. It's got its own properties. In summary, if you look at the form of a general equation of a trig function, y equals a sine of bx or a cosine of bx or a tangent of bx, then the amplitude is represented by the number in front, the a value, right? So here the amplitude is going to be absolute value of a. Amplitude is always an absolute value. It's a positive number. Absolute value of a. An absolute value of a. That's going to be your amplitude. If you want to take a look at the period, let's see what the period was. On the original sine function, the period was 2 pi. What happened to the sine function when we took a transformation of it? Say we took a look at this transformation. Sine divided, or sine 2 theta. Right? Sine 2 theta, the green function. What's the period of sine 2 theta? Right here, sine 2 theta. What's the period of that function from here to here? Pi units. Right, so what that 2 did is, it basically was a horizontal compression by 1/2. So the period got cut by 1/2. So as a result, if the normal period is 2 pi, then any transformation b we have over here is going to make the period 2 pi over b. Right? It's going to get multiplied by a scale factor of 1 over b, whatever that b value is. Similar thing for cosine. Period is going to be 2 pi divided by b. It's normally 2 pi, but whatever that b value is, that's going to either expand or compress that period of 2 pi. What about for tangent? What would it be for tangent? What's the normal period for tangent? Pi. Instead of being 2 pi over b, it's just going to be pi over b. And period is also an absolute value. It's measured just in the positive value, so I'll put absolute value around that b. Right? Just to make sure that the period is not a negative number. Period is going to be a positive value. The amplitude is going to be a positive value. Okay, so to finish things off, we're just going to apply all of this stuff that we've learned. So just by looking at that equation, can you tell me what the amplitude and the period is? So for the first equation, what is going to be the amplitude? Amplitude is going to be 3. What's going to be the period here? Notice it's y equals 3 cosine 4x. It's gotten horizontally compressed by a factor of 1/4. So your period is going to be 2 pi over 4, which is the same as pi over 2. So that means this graph is going to cycle every pi over 2 units. It'll start at 0, end at pi over 2. Start at pi over 2, end at pi, and then so on and so forth.